Installed cameras capturing an eruption from the Black Diamond Pool at Yellowstone National Park on Saturday.
Here's the footage released by the USGS. It shows the eruption blasting out of a thermal pool, sending water several feet into the air.
Satellites orbiting high above the American West have picked up an unmistakable signal. The ground in and around Yellowstone has been lifting at a pace that geologists describe as extraordinary. The imagery is stark, showing subtle but persistent swelling across a broad region that stretches well beyond the famous geyser basins and caldera rim. In response to this, experts have issued what they classify as a red alert, the highest tier of concern within the framework of volcanic monitoring. It is not an announcement made lightly. A red alert signals that the geologic system beneath Yellowstone is undergoing changes rapid enough, large enough, and sustained enough to warrant immediate attention. Before we start, smash the like and subscribe buttons for more updates. The uplift itself is not a mere bump in the soil. Measured in centimeters each year, the bulging represents an enormous volume of magma and superheated fluids forcing their way upward, pressing against the crust like steam building under a kettle's lid. The satellites are able to capture this rise with exquisite precision, mapping the subtle undulations of the Earth's surface as they evolve. What alarms scientists is not only the speed of the uplift, but also its breadth. Instead of a localized bulge, the swelling spans many miles, a signature that deep magmatic reservoirs are shifting and expanding. Geologists who specialize in Yellowstone have long tracked ground deformation, but the current readings show a surge far more dramatic than the slow breathing motions usually recorded. The land has been moving steadily upward in a way that suggests new injections of molten material are flooding into chambers beneath the caldera. Such movement can change the entire stress state of the crust, altering fault lines, bending rock layers, and potentially fracturing pathways through which magma and gases might eventually escape. This is the type of signal that prompted the immediate escalation to a red alert. The term uplift may sound benign, but in a volcanic context, it points directly to pressurization. Think of a balloon being inflated. The skin stretches, thins, and strains under the mounting pressure of the air inside. Yellowstone's crust is that balloon, except it is a patchwork of rock fractured by past eruptions and weakened by circulating hydrothermal systems. Each millimeter of lift captured by satellite corresponds to vast volumes of pressurized material straining against this crust. The red alert is therefore not a prediction of eruption, but a recognition that the system has entered a volatile state where the balance of forces has shifted toward instability. What makes Yellowstone such a focal point for global scientific attention is its scale. Beneath the national park lies one of Earth's largest volcanic systems, often called a supervolcano. Its history includes titanic eruptions that blanketed North America in ash, altered climate, and reshaped landscapes across continents. The presence of a magma chamber tens of miles across means that even moderate injections of new material are measured not in cubic meters, but in cubic kilometers. Thus, when satellites record uplifts spanning dozens of miles, geologists understand it as the surface ripple of gargantuan subsurface processes. The red alert also reflects how unusual the signals are when compared to past decades of observation. Yellowstone does indeed breathe. Uplift and subsidence cycles are normal. But the current episode is stronger, sharper, and faster. Some areas have risen more in a few months than they typically do in years. These rates suggest that magma and hydrothermal fluids are entering the system with unusual intensity. The alert is designed to ensure that every possible instrument is trained on the region, from ground-based seismometers to gas sensors, to catch any escalation before it accelerates further. What satellites cannot show, but what geologists infer, is the movement of magma through conduits and reservoirs. The Earth's crust under Yellowstone is a labyrinth of partial melts, hot fluids, and volatile-rich pockets. When fresh injections arrive from deeper in the mantle, they can destabilize this network. Rock cracks under the added stress, earthquakes multiply, and fluids flash into steam, feeding geysers and hot springs with renewed vigor. Already, geologists are reporting changes in hydrothermal activity, with some geysers showing unusual behavior that mirrors the uplift signals. These surface changes are like the splashes from a hidden wave beneath the ground. The implications of a red alert extend far beyond scientific curiosity. Yellowstone sits atop a hotspot that is among the most carefully watched volcanic regions on Earth. A swelling caldera floor means an increase in pressure, And while that does not guarantee an eruption, it significantly raises the stakes. The uplift represents a system under stress, and stress systems can shift rapidly. Eruptions, if they occur, can come in many forms, from localized hydrothermal explosions that tear craters in the ground, to larger magma-driven events that release ash and gas across wide areas. Geologists emphasize that the red alert is not a forecast of scale, but rather a warning that the energy within Yellowstone's volcanic system is accumulating. For decades, Yellowstone has been the subject of both rigorous scientific study and popular fascination. Its potential as a supervolcano often captures public imagination, but geologists work to separate speculation from measurable evidence. The satellite data, however, cannot be brushed aside. When the Earth's surface lifts across tens of miles, it is the clearest signal of subsurface pressurization available. The red alert acknowledges that the system is restless in a way that exceeds ordinary background levels. This moment is historic because it highlights the cutting-edge use of satellite monitoring as an early warning system for one of the planet's most powerful natural features. The energy involved in the uplift is immense. Each centimeter of rise across Yellowstone represents the displacement of billions of tons of rock and soil. This is not motion driven by tectonics alone, but by buoyant magma and volatile fluids pushing relentlessly upward. The red alert thus signals an event where forces from deep Earth are actively reshaping the surface above. To the trained eye, these patterns echo the opening act of volcanic unrest seen in other regions, such as in Iceland or Hawaii, where uplift and seismic swarms preceded eruptions. But Yellowstone is unique in scale, and that uniqueness magnifies the weight of the satellite findings. Even as the ground swells, scientists stress that the system remains enigmatic. Uplift does not always culminate in eruption, but it always matters. The crust can absorb stress for a time, adjusting through small quakes and hydrothermal venting. However, each adjustment brings new unknowns. The red alert ensures that all monitoring networks remain at peak readiness, watching for those crucial next signals: sharp earthquake swarms, surges in gas emissions, or rapid acceleration of uplift. These would provide more direct evidence of magma moving toward the surface. The broader implication of the alert is a reminder of Earth's dynamism. Yellowstone is not a dormant relic, but a living, breathing volcanic system. The uplift demonstrates how energy from the planet's mantle continues to feed this hotspot, forcing its presence onto the surface. The red alert is, in essence, an acknowledgement of that vitality. It underscores that beneath the serene landscapes of Yellowstone, its forests, rivers, and wildlife, lurks one of the most formidable natural systems on the planet, capable of sudden and profound change. At the same time, the very act of declaring a red alert is a testament to human advancement. Never before in history have we possessed the ability to watch the Earth deform in real time from orbit. Satellites provide an unblinking eye, able to measure ground movement down to millimeters. That capability transforms how geologists understand unrest. The alert is not based on fear or speculation, but on empirical data that shows the Earth itself shifting. It is a powerful reminder that technology now allows humanity to peer into processes that were once invisible, giving society precious lead time in the face of geologic volatility. As the ground continues to lift, each new satellite pass brings fresh data. Scientists pore over interferograms that reveal where the swelling is most pronounced, noting the spread of concentric rings of uplift like ripples in a pond. These rings point towards central zones of pressurization, where magma is pooling or expanding. Such imagery is a direct fingerprint of the forces at work. The fact that these patterns now warrant a red alert suggests that the system is pushing against limits previously unseen in Yellowstone's monitoring record. For now, the uplift is the story. The steady, insistent rise of land across one of the world's most iconic landscapes. It is a story written in satellite pixels, confirmed by ground instruments, and recognized by geologists as a signal that cannot be ignored. The red alert is the scientific community's way of saying the Earth is speaking loudly beneath Yellowstone, and the world must listen. The satellites that first revealed Yellowstone's unusual uplift have set in motion a flood of investigations across the geological community. With every new reading, specialists are piecing together a more nuanced picture of what is happening beneath the caldera. This is not a single pulse of motion, but a complex interplay of pressure, heat, and structural weaknesses across a vast volcanic system. As the red alert status continues, the focus turns to the deeper processes driving these movements, the mechanics of Yellowstone's hidden magma body, and the broader significance of such dramatic signals from the Earth's interior. What underlies the current concern is the architecture of Yellowstone's volcanic plumbing. Unlike a simple cone-shaped volcano with a straightforward conduit to the surface, Yellowstone rests atop an immense layered system of molten and semi-molten material. There are at least two main magma reservoirs, one shallow chamber lying only a few miles beneath the surface, and another deeper zone that reaches into the upper mantle. These two reservoirs communicate with one another, and it is this exchange that fuels both the spectacular hydrothermal features at the surface and the long-term cycles of volcanic activity. When satellites detect ground rising across a wide region, it suggests that one or both of these reservoirs is being replenished, pressurized, or otherwise disturbed in ways that add stress to the crust above. Geologists often describe Yellowstone as a living laboratory for understanding how supervolcanoes function. Every cycle of uplift and subsidence adds another chapter to that laboratory record, but the current uplift is rewriting expectations. Normally, such deformation occurs slowly, almost imperceptibly over decades. Yet the pace measured in recent months is many times faster than average, forcing researchers to consider whether magma pulses from deep in the mantle plume have recently surged upward with unusual vigor. If so, that would mean that Yellowstone is not simply breathing, but actively being fed by new material that is reshaping its reservoirs in real time. The key to understanding these processes lies in combining satellite data with other streams of observation. Ground-based seismometers capture the earthquakes that accompany shifting stresses. When magma moves, the surrounding rock fractures, releasing small quakes that form swarms. These swarms can migrate across the park, tracing invisible paths where magma and fluids are forcing their way forward. A notable increase in such swarms, coinciding with the satellite-detected uplift, further validates the seriousness of the red alert. Gas emissions provide another line of evidence. The balance of carbon dioxide, sulfur dioxide, and other gases rising from fumaroles often changes as magma ascends. Any uptick in such emissions during uplift episodes is a sign that the crust is becoming more permeable, releasing the volatiles that had been trapped underground. Hydrothermal activity is particularly sensitive to these changes. Yellowstone's geysers, hot springs, and mud pots depend on the circulation of water through hot rock. When the crust uplifts and fractures, new pathways open. Springs may become hotter, geysers may erupt more frequently, or entirely new features may appear. Scientists treat these changes as windows into the larger, hidden processes. The red alert has already spurred teams to intensify their monitoring of hydrothermal features, as they often act as the first surface indicators of deeper unrest. Even slight shifts in their behavior when matched with the uplift signals strengthen the conclusion that magma injections are reshaping the volcanic system. The scale of Yellowstone means that even small percentages of melt can represent enormous volumes of material. For example, geophysical studies suggest that the shallow reservoir may be filled with only about 5–15% molten rock, with the rest being semi-solid. Yet given the chamber's size, tens of miles across, this percentage still equates to thousands of cubic kilometers of magma. When satellites detect uplift, they are essentially witnessing this partially molten mass being pressurized, either by additional magma flowing in or by gases expanding within the chamber. Both scenarios demand vigilance, as they represent conditions where the system edges closer to instability. The declaration of a red alert carries implications beyond Yellowstone itself. It demonstrates how interconnected Earth's processes are. The Yellowstone hotspot is thought to be fed by a mantle plume, a rising column of heat and material from deep within the Earth. Such plumes are among the most powerful geological engines, responsible for vast volcanic provinces and continental reshaping over geologic time. That Yellowstone's plume is actively pulsing upward today reminds scientists that Earth's interior is far from static. Every surge of activity at Yellowstone reflects broader planetary processes, connecting the surface we see with the deep mantle hundreds of miles below. In practical terms, the alert also mobilizes resources across scientific and governmental institutions. Research flights equipped with sensors now sweep across the park, measuring gases and magnetic variations that could reveal more about the underground conditions. Ground teams deploy portable seismometers in sensitive zones to increase resolution on earthquake activity. Supercomputers are tasked with running models of how magma might be moving through Yellowstone's crustal labyrinth, testing scenarios to see which best fits the observed uplift. This sudden burst of scientific focus illustrates the magnitude of the event and the seriousness with which it is treated. The psychological dimension of a red alert is equally significant. Yellowstone occupies a unique place in public imagination, and any suggestion of unrest stirs deep fascination. While scientists emphasize that uplift does not mean eruption, they also recognize that people instinctively grasp the connection between swelling ground and volcanic pressure. The red alert thus functions on two levels: as a technical designation for heightened monitoring, and as a signal to the broader world that something profound is happening beneath one of Earth's great natural wonders. On the scientific frontier, one of the pressing questions is whether the uplift reflects localized pressurization in the shallow chamber, or a larger-scale reorganization of the entire Yellowstone magma system. The patterns of uplift, spanning multiple zones, hint at the latter. This would mean that magma is not just inflating a small pocket, but instead interacting with a complex multi-chambered structure. Such interactions can lead to cascading effects, where stress shifts in one zone destabilize others, producing sequences of deformation and seismic activity that ripple outward. Understanding these dynamics is crucial for anticipating the trajectory of the current unrest. Another layer of inquiry involves the chemistry of Yellowstone's gases. As magma rises, it releases gases that were previously dissolved within it. By studying the ratios of carbon dioxide to sulfur dioxide, or the isotopic composition of helium, scientists can determine the depth and source of the magma. In the current Uplift episode, any change in these gas signatures would provide critical evidence for whether the material is fresh magma from deep below or remobilized magma from existing reservoirs. Such chemical fingerprints are part of the puzzle that the red alert has thrust into prominence. Geologists also pay close attention to the mechanical properties of Yellowstone's crust. Decades of uplift and subsidence cycles have left the crust fractured and weakened in places. This patchwork means that the response to new injections of magma is not uniform. Some zones may flex and absorb the pressure, while others may crack suddenly. The satellite data showing widespread uplift suggests that stress is being distributed unevenly, and pinpointing where the crust is most likely to give way becomes a priority. These structural weak points are potential sites for hydrothermal explosions, or in more extreme scenarios, vent formation. Comparisons to other volcanic systems help place Yellowstone's uplift in perspective. In Iceland, uplift episodes have preceded both moderate eruptions and non-eruptive periods of unrest. In Hawaii, similar patterns have been linked to the migration of magma into rift zones. But Yellowstone is not easily compared because its scale and underlying mantle plume create dynamics unlike those of smaller oceanic volcanoes. The red alert, therefore, highlights Yellowstone's uniqueness. The signals may resemble those seen elsewhere, but the implications are magnified by the sheer size of the system. What satellites capture is only part of the story, but it is the most visually compelling. The interferograms, with their concentric colored fringes representing centimeters of uplift, look almost like abstract art. Each fringe is evidence of Earth's crust rising under pressure, a tangible record of processes occurring miles beneath our feet. For geologists, these images are more than data. They are windows into the heartbeat of Yellowstone. The red alert is built on this imagery, translating colors on a satellite map into a recognition that the system has crossed a threshold of significance. One of the most intriguing aspects of the current uplift is its potential to reshape Yellowstone's surface in subtle ways, even if no eruption occurs. Lakes may tilt as their basins are deformed, altering shorelines and flow patterns. Rivers may shift course slightly, responding to the changing gradients. These surface adjustments are minor compared to volcanic eruptions, yet they are reminders that the land itself is being bent and reshaped by deep forces. Scientists expect to see such changes in coming months, documenting them as further evidence of the uplift's impact. The broader scientific value of this red alert lies in the unprecedented chance to observe Yellowstone's system in a highly energized state. Each data set collected during this period seismic, geodetic, geochemical, will add to humanity's understanding of how supervolcanoes behave in real time. While the uplift itself may eventually subside, the knowledge gained will endure, informing how geologists interpret signals not only at Yellowstone, but at other volcanic systems worldwide. The red alert thus represents both a warning and an opportunity. A warning of potential volatility, and an opportunity to study Earth's forces in their rawest form. For the people who live in the region, the alert is a stark reminder of Yellowstone's dual identity. A place of immense beauty and immense geologic power. The meadows, forests, and geysers draw millions of visitors each year, yet beneath that tranquil surface lies a system now flexing with renewed strength. The red alert does not predict an outcome, but it underscores that the land itself is shifting on a scale visible from space. It is a moment that binds the local experience of Yellowstone's landscapes with the global scientific recognition of its power. As the uplift continues, geologists remain on constant watch, parsing every tremor, every gas release, every centimeter of rise. The red alert is not the end of the story, but the beginning of a new chapter in Yellowstone's ongoing saga. It is a chapter defined by movement, of magma, of rock, of water, and of scientific understanding. The satellites that first sounded the alarm will keep circling overhead, recording the pulse of a supervolcano that refuses to be silent. For now, what matters is not aftermath or outcome, but the recognition that something extraordinary is happening beneath Yellowstone, and the world is witnessing it in real time. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Yellowstone's uplift? Natural cycle or imminent eruption? We want to hear from you. Thank you for watching and see you next time.